निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
In this lesson, we will be studying chapter 12, areas related to circles. The introduction and solution to exercise 12.3. This exercise is related to the area of combination of simple figures. Area of combination of simple figures. Simple figure means we are talking about two-dimensional figures, square, rectangle, circle, and the combination will be given to us and we will have to deal as per the problems that are given to us. So we will be dealing with areas of such two-dimensional figures in a combined form. Let us deal with the first example. That is example number 4 from NCERT textbook. In the given figure, so this is the given figure to us, two circular flower beds have been shown on two sides of a square lawn ABCD of side 56 cm. If the center of each circular flower bed is the point of the intersection of O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. That means ABCD, this is a square lawn. Initially it is given to us as it is a square lawn whose each side is 56 centimeters. And these two are the flower beds. These two are our flower beds. And we need to find the area of the whole. That means area of the square lawn plus the area of the two flower beds. This can be done in two different ways. We can find the area of this part, area of this part, and area of the square and add it. This is one method that we will be getting the area of the whole, or else we can make it small parts. We can find the area of this triangle BOC, we can find the area of this triangle AOD, we can find the area of the sector BOA, and we can find the area of the sector COD and add all the four parts. This part plus this part plus this part plus this part. These are the two methods we can find. But before moving on to that, if we are to find this segment, then also we need a radius. Or if you follow the second method, if this is a sector, then also we need the radius. That means what is the radius out here? So in order to find the radius for a part of a circle that is sector, we need to find out that. So let us consider our solution. First of all, to find, since ABCD is a square, so AB is equals to BC is equals to CB is equals to AD. All will be equals to 56 centimeters, and we know diagonals of a square bisect each other perpendicularly. That means this angle is 90 degree and the diagonals of the square are also equal. So this is equals to this, and since this AC is equals to BD, so you can say OA is also equals to OB and OC is also equals to OD. That means all OA, OB, OC, OD are equal. Now let us first of all find out what is OA or what is OB. Let us find out. So let us take a triangle. In triangle, say A, B and C. From triangle ABC, we are given with AB is equals to 56 centimeter, BC is 56 centimeter. We can find AC, and if you half the AC, you get the radius for the circle. So let us find AC. So by Pythagoras theorem, we know AC square is AB square plus BC square. So this is 56 square plus 56 square. That means if you take 56 square common, this is 1 plus 1. This is 56 square into 2. Then AC is equal to root under 56 square into 2. So this is 56 root 2. So you have got the diagonal AC to be 56 root 2. Let us find OA, or what we call it as OA is equals to OB is half of BC. So this is half into 56 root 2, so this is 28 root 2 meters. So we have got the radius now. Now we will be finding the total area of the square lawn plus the two flower beds. So we will be moving on to that part by part form. We will find the area of this sector, we will find the area of this sector, we will find the area of this triangle, we will find the area of this triangle, and then we will add as a whole. So we can do it directly. We can say total area of square lawn plus flowers, that is equals to area of sector OAB plus sector COD the area, you can say the area of sector COD plus area of triangle AOB plus area of triangle BOC. Just check it. Are we correct? The area of this sector plus area of this sector plus area of this triangle plus area of this triangle will be by the total area of the square one plus the flower bed. Now area of the sector OAB will be equals to the area of the sector COD, as the radius are same and the central angle is 90 degree for that, plus area of triangle AOD and area of triangle BOC will also be same because both have same base and same height. So let us find area of sector OAB. So this will be 90, that is theta by 360 into pi r square. Let us take pi to be 3.14, 22 by 7. That will be much easier for us. 22 by 7 into r square. R square means radius square. What is the radius that we had got? 28 root 2. So you could have written OA is equals to OB is equals to OC is equals to OD is equals to R is equals to 28 root 2. So let us substitute here. 28 root 2 into 28 root 2, this is 28 into 28, and root 2 into root 2 is 2. So this is the area of the sector OAB plus the area of the sector COD. So you can directly multiply with 2 as both have same areas, plus area of the triangle AOD, that is half into OA into OB, and in place of OA there is base into height. In place of OA you could have it at 28 root 2 into 28 root 2. So this is the area of triangle AOD. And since the area of triangle AOD and area of triangle BOC is same, you could have multiplied this also by 2. Now solve it to get the answer. This is 90 7 4 and 4 4 cancel. So you have got here 22 into 28 into 2 whole into 2 plus. Let us solve here also. Root 2 into root 2 is 2 and that 2 is cancelled. So this 2 and root 2 need to cancel. This is 28 into 28 into 2. So just simplify and get the answer. This is 22 into 56 plus 28 784 into 2. Let us multiply 56 with 22 somewhere. 56, 22, 112, 112. This is 2, 3, 2, 1, 2, 3, 2. And into 2 we have left out, into 2 plus. This is into 2. So this is 4, 6, 4, 2, 2, 4, 6, 4, 2, 4, 6, 4 plus 7, 84 into 2 is 8, 16, 6, 1, 15, 1, 5, 6, 8. If we add it plus 1568 2304. So this is 4032 meter square. So the total area of the square lawn along with the flower beds is 4032 meter square. Next example. Example number 5. Find the area of the shaded region in the given figure. The figure is given to us where ABCD is a square of side 14 cm. ABCD is a square of side 14 cm and there are 4 circles of equal dimension, that means of equal radius or of equal diameter, whatever you say. 4 of the circles are congruent circles with each radius same. We need to find the area of the shaded region and the circles are the unshaded part. In order to find the area of the shaded region, we will have to find the area of the square and we will have to subtract the 4 circles from it because these are unshaded. The rest all part is a shaded. In order to find the area of the circle, we need to first find the radius of the circle. How will we find the radius of the circle? Let us go through it. ABCD is a square of side 14 centimeters. So this is side 14 centimeters. So if we draw a line this way, this line is also 14 centimeters. Say EF is also 14 centimeters. Then what is EF? These are the 2 diameters. Diameter of this circle plus diameter of this circle. So 2 circles, 2 diameters, length is 14 centimeters. So we can say the diameter of 2 equal circles, diameter of 2 equal circles is 14 centimeters. The diameter of 1 circle, or you can say each circle, is 14 by 2, that is 7 centimeters. That's all. If diameter of each circle is 7 centimeters, then what can we say regarding radius? So we can say radius of each circle is 7 upon 2 centimeters. So we have got the radius of each circle. Now in order to find, once again let me tell you, if you want to find the area of the shaded region, we will have to subtract all the 4 circle area from the total area of the square. So we can write total shaded area, that is equals to area of the square ABCD minus 4 circles. So 4 into area of each circle. We can write area of the square ABCD minus 4 circles we have. So area of each circle into 4 is total area of the 4 circles. That is to be subtracted from the total area of the square lawn to get the area of the shaded region. Let us solve it. So what is the area of the square? Area of the square is side into side. So you can say what was the length of the side? That is 14 centimeters. So area of the square is 14 into 14 meters square. Is it meters or centimeters square? Minus 4 into area of each circle. Area of circle is given by pi r square and 4 times of pi r square. So let us 14 into 14, 196 centimeters square minus 4 into the value of the pi is 22 by 7 and the radius is, what is the radius of the circle that we have calculated? That is 7 by 2. So into 7 by 2 into 7 by 2. Solving this part, we will be getting the area of the shaded region. So 196 centimeters square minus, that is simplified, 7 cancels, 2 2s are and 2 into cancels. 22 into 7. 22 into 7 is 132 centimeter square. And if you subtract it, you get 6 minus 2, 4, 9 minus 3, 64 centimeter square. Let's check once again whether our calculation is correct or not. 14 into 14, that is 196 centimeters square, minus 4 into pi, 4 pi r square. That's correct. Then 7 cancels, and this cancels. 22 into 7. 22 into 7 is not 132. There is a mistake. 7 into 14. This is 4 and this is 154. 7 to 15, 4, 1, 15, 154. There is a mistake. We should have. So this is 42 centimeter square. So now we have got the exact 42 centimeter square is the total area of the shaded region that is required in example 5. So example number 6. Find the area of the shaded design in the figure that is given. Where ABCD is a square of side 10 centimeter. So ABCD is a square of side 10 centimeter. All the four sides are same. AB is equals to BC is equals to CD is equals to AD. And semicircles are drawn with each sides. The semicircles are drawn. This is a semicircle that is drawn. This is a semicircle is drawn. Semicircle is drawn with diameter as the side of the square. That means the diameter of each semicircle is the side of the square that is equals to 10 centimeter. We need to find the area of the shaded region. Shaded region. In the previous question also we had discussed that area of the shaded region can be calculated by area of the total square minus area of unshaded region. So here the unshaded region is 1, 2, 3, 4. There are 4 unshaded regions. Let us mark those unshaded regions as. Let us mark the unshaded region. The unshaded regions as 1, 2, 3, and 4. Let us mark. Say this is 1, this is 2, this is 3, and this is 4. These are the 4 unshaded regions that we have marked in the figure. Now, in order to find the area of unshaded region, we will have to consider 2 semicircles along with the square at a time. Suppose we need to find the area of unshaded region 1 and 3 together can be found out by area of the square minus area of this semicircle minus area of this semicircle will give me the area of unshaded region, that is 1 and 3 together. So area of 1 plus 3 is equals to, that is area of square minus area of 2 semicircles. For 1 and 3, which 2 semicircles we are taking? When we are finding these 2 areas together, this is the semicircle, this is the semicircle that we are considering, and from the whole area of the square we are subtracting both the semicircles to get the area of unshaded region 1 and 3. Similarly, that could be done for the region 2 and 4 also. From the whole square, subtract this semicircle part, subtract this semicircle part, and you get the area of 2 and 4. And the value will be same for 1 plus 3 will be equals to 2 plus 4 because all the semicircles are of same diameter and the same square is being used. So we will be calculating now first area of the unshaded region, that is 1 and 3 together taken will be equals to the area of the square minus area of 2 semicircles. Area of the square area is side square or side into side. Here the side is 10 centimeter. If you want to write the formulas first, then also we can write side square minus area of 2 semicircles means 2 into half pi r square. Half pi r square is the area of the semicircle, and since there are 2 semicircles, so 2 into half pi r square. Now we can substitute the values. The side is of the square is 10 centimeter, so 10 into 10, this is the area of the square minus, this can cancel out here, pi r square, we have to take pi as 3.14 into the radius is, since the side of the square is the diameter of the semicircle, so the radius will be the half of the side of the square, so radius is 5 centimeters, 5 into 5, so this is 100 minus 3.14 into 25. So this is 100 minus multiplied 25 goes up 100. This is 10, 35, 5, 3, 78.5. If you subtract 78.5 from 100, you get 21.5 centimeter square. This is the area of the unshaded region taken together as 1 and 3. Similarly, we will be moving from unshaded region 2 and 4. We will again get the same area. So area of 2 plus 4 can also be taken as 21.5 centimeter square. So this is area of 1 and 3 unshaded region. This is area of 2 and 4 unshaded region. And now we can find the area of the shaded region. So area of shaded region is equals to area of square minus area of 1 plus 2 plus 3 plus 4. That is the unshaded region. So area of the square is again, this is side square, we know that, and area of 1 plus 2 plus 3 plus 4, 1 plus 3 is 21.5 and 2 plus 4 is 21.5. Taken together, we can keep this way. So this is area of square is 10 square minus 43. This is 100 minus 43 is equal to 57 centimeter square. So the area of the shaded region that we require from our question example number 6 is given by 57 centimeter square, which was calculated by the formula area of the square minus area of the unshaded region. Let us begin with the exercise 12.3. The very first question of the exercise 12.3 from NCERT textbook. Find the area of the shaded region in the given figure, that is figure 12.19. If PQ is equal to 24 centimeter, PQ, so this one is 24 centimeter, this PQ is 24 centimeter, PR is 7 centimeter, so PR is 7 centimeter, and O is the center of the circle, and O is the center of the circle. Now if you observe, if O is the center of the circle and QR is the line passing through the center, so now the QR can be considered as the diameter of the circle. So let us first do that. That QR is the diameter. Now if this is the diameter, in class 9 we have gone through a theorem that angle in a semicircle is a right angle. Now this is one semicircle, this is one semicircle. So the angle formed in the semicircle, this one is a right angle, this will be 90 degrees. So we can say angle RPQ is equal to 90 degrees. The reason is angle in a semicircle is a right angle. That is, angle in a semicircle is a right angle, that is the angle is 90 degrees. Now if you see, we have a triangle PQR. What for do we need this triangle? We need this triangle to find the diameter. From the diameter we will be getting the radius of the circle, and then we will be talking about how to find the area of the shaded region. But before finding or talking about the shaded region, let us first find the radius of the circle. Before that, we need to find the diameter of the circle. So let us move on with in triangle PQR. By Pythagoras theorem, we know that base square plus height square is equal to hypotenuse square. So we can write PQ square plus PR square is QR square. So PQ, that is 24 square, plus 7 square is QR square. This is 576 plus 49 is QR square. 625 is QR square. So QR is 25 centimeters. Now this is the diameter of the circle we have got. So radius, you can say OR is half of QR, that is equals to 25 by 2 centimeters. So we have got the radius of the circle, but we haven't got the area of the shaded region yet. Now we'll be talking about the area of the shaded region. The area of the shaded region, this part and this part is the shaded region part, and the total shaded region part lies in the semicircle of the triangle. If you observe it very clearly, area of shaded region can be equal to area of the semicircle minus area of the triangle. So in this semicircle, if you subtract the area of the semicircle, if you remove this unshaded part, you get the shaded part. So we can just continue with that. The area of the shaded part, area of shaded part or shaded region, whatever we want to write, is area of semicircle, area of semicircle minus area of triangle PQR. The area of the semicircle is given by the formula half pi r square and minus area of the triangle PQR is a right angle triangle. The formula is half into base into height. So this is half pi can be taken as 22 by 7, and the radius of the circle we had calculated 25 by 2. So it's 25 by 2 into 25 by 2. So this total is the area of the semicircle minus half into base into height. If you consider 7 as a base, then the height is 24. So this is half into base into height. This is the area of the triangle. Calculating and simplifying, we will get the area of the shaded region. So let us continue with the simplification. So this 11 is up. So you have 11 into 625 by 28 minus 12 into 7. This is 8. So 625, 5, 7, 7, 6, 8, 7, 5, 6, 8, 7, 5 minus 84 into 28, 3, 6, 7, 2, 8, and 16, 2, 5, 3, 1, 3, 5, 2 by 28. And this will also be equals to 6, 8, 7, 5 minus 1, 3, 5, 2 is 3, 2, 5. Is it? We are getting this 5, 5, 2, 3 by 28. 5, 5, 2, 3 by 28 centimeter square. So this is the area of the shaded region. Let us check it once again before moving on to the next question. Area of the shaded region is area of the semicircle minus area of the triangle. Area of the semicircle is half pi r square minus half into base into height for the area of the triangle. Half pi is 22 by 7 and radius is 25 by 2 that we have got. We have got the diameter to be 25 and the radius is 25 by 2. Then 25 by 2 into 25 by 2 minus half into base into height. This is 2, 3, this is 2, the calculation mistake. So this is 4, 5, 2, 3 by 28 centimeter square. Now to the next question of exercise 12.3, question number 2. Find the area of the shaded region in the given figure that is given to us. If the radii of two concentric circles with center O, we have two concentric circles with a common center, and the radii of both the circles are given to us as 7 centimeter and 15 centimeter. That means OB is 7 centimeter and OC is 14 centimeters. This is given to us, and angle AOC is equal to 40 degrees. This is also given to us. We need to find the area of the shaded region. A very simple and easy question. Here, if you observe, we have two sectors. This is OBD and the second sector OAC. In order to find the area of the shaded region, we can find the area of the shaded region by subtracting the smaller sector from the bigger sector and we get the answer. So we can write that area of shaded region directly can be done area of shaded region is equals to area of sector, that bigger sector OAC, minus area of smaller sector, and that sector is OB. And area of the sector is always given by theta by 360 into pi r square. So we can write theta by 360 into pi 14 square, the radius of the outer sector, the bigger sector, minus theta by 360 into pi 7 square, where theta is 40 degree. We will be substituting the value of theta and pi also, so and we will be getting the answer for the area of the shaded region very easily. So theta is 40 by 360, the value of pi is 22 by 7 into 14 into 14 into 14 into 14. So this is the area of the outer sector or the bigger sector, you can say, minus theta, that is 40 by 360 into 22 by 7 into 7 into 7, that is the radius of the smaller sectors. Let us simplify it. 40 9 7 2. So this is 22 into 28 by 9 minus. This is again 9 7 7 cancel. 22 into 7 by 9. If you solve it, if you take 22 by 9 common, this is 28 minus 7. So this is 22 by 9 into 21. Is that correct? 22 by 9, 22 by 9, this is 28 minus 7. And this is 3 3s are 3 7s are 22 into 7, 154 by 3 centimeter square. So the area of the shaded region in this concentric circles with two different sectors of radius 7 centimeter and 14 centimeter is 154 by 3 centimeter square.